Okay, so milling lab number 2, and the first thing we do on the input screen here is we're going to go to part setup and change our stock geometry. The stock geometry for this one is going to be 70 millimeters by 70 millimeters, and it's going to be 40 millimeters thick. The offsets then for this one, there's no X offset. The Y offset is going to be minus 70, and the Z offset is going to be 30. So if we do a quick draw to check the shape that we have, we can see the block of material, and if we rotate it, we can see the origin on the back corner 10 millimeters up, which is our corner of our vise. So the first thing we're going to do is machine the top face. So we can go back to our input screen, part programming, milling, and face. So the X corner can be minus 10. The Y corner can be plus 10. Okay, and then we're going to machine a length of 80 in the X and minus 80 in the Y. Our Z start's going to be 30, and let's go down to 28. This type of tool then is going to be a face milling tool, so we can select tool from list and face mill diameter 80, select tool. And we'll go in X unidirectional, we're going to go X bidirectional, or it could be Y bidirectional. Our speed and feed, you need to work them out on the calculations that we showed in class, and we'll go for 1 millimeter peck depth and plunge speed of 100. So that's our first operation. So we do a quick draw to check that out, that we've machined the part correctly. I'm just going to zoom right out here and see what's happening. Alright, the cutter's 80 millimeters diameter, that's why it starts so far out. That's fine. We can go to end of program, and we'll go to insert block before. And what we want to do here is we want to create, if we just look at the notes, the drawing here, or the notes that are up on Moodle, we've set the size. We want to create this island, this red island as such. So this matches the drawing that we have of the component. This part here that's up stud, if you like. So we want to machine everything but that. So what we do here is, if we go back to, we do a milling operation. And what we can do here, we can do a frame. Alright, and our X corner, Y corner, again we're going to start them just outside the part. So we can actually have that at minus 5 and Y is 5. So we're outside of the part. And again we need to go the length of the part, and the length of the part was 70. And we're adding on 70 and 5 and 5. So it's going to be 80 long, minus 80 in the Y. The Z start now could be 28, I think we were at. And our Z bottom needs to be the height of the component that we want to leave. So if we look at the drawing here, that's a 3 millimeter drop here on the top of the part. So it's this 10 less 13. So that's 25 we're going down to. And no corner radiuses. And the tool here we're going to pick is a small end mill. So we're going to pick a diameter of maybe 10 or 12 end mill and select tool. And the milling type is a new one. It's a thing called a pocket boundary. So it's going to machine everything inside this frame we defined, pocket boundary. And it's an inward pocket boundary. And if we just check our geometry at the moment, we can see that we just machine everything. The yellow cut there, it machines everything inside the pocket. But as we've seen from our drawing and our notes, we want to leave this red island, we refer to it as, in the component. So if I go back here to my program, and I can go to my data blocks, and I'm going to insert block before, and this is going to be a milling operation, and it's going to be a circle. And I need to define the center of the circle, so I'm working off a 5 millimeter offset in the part, I think it was. So my center is actually going to be 35 minus 35, and my radius of my circle is going to be 22.5, I believe. And straight away, before I fill anything out, the milling type, I can change it to a thing called a pocket island. And that's all the data I need to do. Now when I draw the part, it should leave an island in the middle, being the circle. So we can see the island being left. The boundary we cut outside here, which is the blue box, and then the circle is the island left in the middle. So make sure we go back to our input screen and we make sure we're saving our part there, MilLab 2, and we can continue on from that and do a similar. Just look at the notes a second. The next step we look at here is to create the circle in the center, that orange circle, which again is a milling operation, and we'll do that now. So at the end of the program, we're in data blocks here, end of program, insert block before, milling, circle. And again, we use the exact same x and y coordinate. That should be 35 minus 35, and the radius here is 15. Our Z start should be the top of the part, which was 28, and we're 10 deep, so we're 18. Start angle we leave at 0. The tool, we're going to pick a diameter 10 N mil, and it's going to be a thing called a pocket boundary. So it's everything inside the pocket and it's inward. So now we see if we enter the correct feed and speed that you should work out from your calculation. We do a draw, draw, and draw. And that's the top of the block completed. Now we could add to this component that we need to do the frame around the outside maybe and the tap toes. So we'll go back to the data blocks. We're going to insert a block before, milling, and frame. The frame is going to be our component. So we're in 5 and down 5, and our length of our part is 60 and minus 60. We can start at 28, and we need to go down to the bottom of the part, which is going to be around the minus 15 mark there. So even 18 down to 13 should be fine. Corner radius we can set there at 10 as per the drawing, and the tooling is select tool from list. It's going to be just a large end mill, maybe a 16, and it's outside. And again, you can fill in the feeds and speeds on your worksheet. So if we do a quick draw on that, we should see that our island, our pocket, our frame on the outside, and I hit rotate there. I'm getting the different colors because I'm using different tools for the different blocks. The final block we want to look at, insert block before, holes, and we can just do a drilling operation here. Should be okay. And we're going to do a drill. Okay, our Z start is going to be 28, and our Z bottom, we're going to go the whole way through, so let's go down to 10 on the part. The tool we're going to pick here, we can select tool from list, is a drill diameter 5, because we're going to tap it M6, and again you can work out your feed and speed. Our next hole operation, straight after our drill, is a tapping operation, and it's a rigid tap we refer to it as. And again we can start at 28, and this time we're just going to go to 10. And the tool that we use here, select tool from list, is going to be an M6 tap, M6 by 1. And again we can look at those speed and operation. We leave 0 as the peck depth because we use a machine tap, go the whole way through. Now we've only defined the Z coordinates, so we need to find the X and Y coordinates of the hole. So we can do next hole operation. And the fact that we're doing a circle, a bolted circle here as such, and we can see it's on a diameter 37.5. So if we go back to the program, we can do this bolted circle here, and number of holes we can pick is 8 holes. X center is 35, Y center is minus 35, radius was 37.5 divided by 2, and start angle we can leave that at 0. And we can actually skip instances here if we want to, but we don't want to skip any. And we'll do a quick draw there to check that. And there's the drilling of the holes and then the tapping of the holes. And that's the component completed there for this model.